Assalamualaikum warahmatullahi wabarakatuh. We are from Group A and this is our presentation video.
Now let me discuss the crucial part, which is future value. The definition of the future value. The future value represents the final amount, initial investment plus total interest, and we will conclude to the simple formula S equal to P plus I, S represent for the future value, P for the original principal, and I for the total interest. And we will use the formula S equal to P bracket 1 plus R bracket power of N. And let's clarify each variable for the formula. S represent for compound amount at the end of an interest period, P for original principal, R for the interest rate of period, and last but not least, N period N represent for periods at the interest rate. And let me move to the question. Compute the compound amount when Badrul has invested 10,000 ringgit Malaysia for 6 years at the nominal rate of 7% compounded semi-annually. First and foremost, let me highlight the significant keyword, which is 10,000, 6 years, 7% and compounded semi-annually. And the solution for the question, we will use the formula S equal to P brackets 1 plus R bracket power of N. We will compute for the future value. P we insert for 10,000 ringgit Malaysia. R we insert 0.07 divided by 2 and we will get 0.035, and N we insert 6 multiplied by 2 and we will get 12, and the final we will insert the amount in the formula S equal to 10,000 bracket 1 plus 0.07 divided by 2 power of 6 multiplied by 2, and we will get 10,000 bracket 1.035 bracket power of 12, and we will use the calculator to get the answer, and the final answer is 15,110.69 ringgit Malaysia.
Next, I'm going to explain about effective rate, which is the definition is the equivalent annual rate of interest which is compounded annually. And the formula is like given here. So for the question is, if Hazika would like to make an investment and she has a choice of investing money at 7% compounded daily or 1/4% compounded quarterly, which is the better choice for her? So in this question, we're going to compare which is the better effective rate for Hazika to invest and earn more money in the future. Let's look at the solution. For choice number 1, 7% compounded daily, N which is period equal to 365 day. And for choice number 2, 1/4% compounded quarterly, which is equal to 7.25%, and N equal to 4. So for choice number 1, with the formula given, we will get 0.0725, which is equal to 7.25%. And for choice number 2, with a formula given, we will get 0.0745 or 7.45%. So Hazika should choose investing money at 1/4% compounded quarterly, which is choice number 2. This is because highest effective rate, more money that Hazika can earn in the future.
Next, present value. Definition: the principal P that must be invested at the periodic rate of R for an interest period to earn the compound amount S. The formula P equal to S in bracket 1 plus R to the power negative n3. Clarify each variable. P means original principal, S compound amount at the end of an interest period, R interest rate of period, and period at the interest rate. Number 4, cash flow, future payments generated from the initial investment. Number 5, net present value, NPV, sum of the present value of the cash flows minus the initial investment. NPV more than 0, investment is profitable. PV less than 0, investment is not profitable. Questions and solution: present value. Applying the formula, Anis would like to earn RM 1,000 after 5 years. What is the present amount should she save now to earn the stated amount if the interest rate is 11% compounded monthly? So the formula, we want find present value. P equals to S in bracket 1 plus R to the power negative n. So P we will find S RM 1000, R 0.11 divided by 12 because compounded monthly. So we get 0.0092 and 12 multiplying with 5, so we get 60. So P equal to 1000 in bracket 1 plus 0.0092 power negative 16 equal to 1000 in bracket 1.0092 power negative 16. So the answer equal to RM 577.25.
Next is the present value interest compounded continuously. The definition is the present value with a continuous compounding is referred to the current worth of sum of money. We will look at the formula, which is P equal to S exponent negative RT. We can clarify each variable, which is N is compound amount of the N of interest period, P is original principal, R is annual interest rate, and T is number of years. The question is a trust fund is being set up by a single payment so that at the end of 25 years, there will be Rm 100,000 in the fund. If interest is compound continuously at the rate of 8%, how much should it be paid into the fund initially? Then we will use the formula P equal to S exponent negative RT, which is S is Rm 100,000. We want to find T. R is 8%, which is 8 divided by 100. We will get 0.08, and T is 25 years. We will use the formula Rm 100,000 multiplied by exponent negative 0.08 multiplied by 25. We will get 100,000 multiplied by exponent negative 2, and we will get 100,000 multiplied 0.135335232, and the answer will be Rm 13533.52832. Next is the future value interest compounded continuously. The definition is the future value with continuous compounding formula is used in calculating the later value of a current sum of money. The formula we will use is S equal to P exponent RT. We can clarify each variable, which is S is compound amount at the end interest period, P is original principal, and R is annual interest rate, and T is number of years. The question is, if Rm 4,000 is invested at an annual rate of 6% compounded continuously, what will be the final value of the investment after 10 years? And the solution, we will use the formula S equals P exponent RT, which is we will find S, and P is Rm 4,000, R is 6%, which is 0.06, and N is 10 years. We will find S, which is 4,000 multiplied by exponent 0.06 multiplied by 10, and we will get 4,000 multiplied by exponent 0.6, and we will get 4,000 multiplied 1.8221188, and the answer will be Rm 7288.48.
So now we move on to the next subtopic, which is annuity. Annuity have two types, which is annuity due and annuity ordinary. So for now, we use the annuity ordinary. This subtopic have two, which is present value of annuity and future value of annuity. So now I will start with the present value of annuity. So what the meaning of that? So the meanings of present value of annuity is the current value of all the income that will be generated by the investment in the future. In short, we do know how much payment in today, and they only have the series of payments. So from that, we can find the present of annuity based on this formula, which is A equal R multiply 1 minus 1 plus R negative N divided by R. So from that, we can find the present value of annuity. So next, what the meanings of terms in this formula? So A stands for the present value of annuity ordinary, and R, they have two types of R, which is capital R and little r. For capital R, it stands for payment periods, and little r stand for interest rate of periods, and the last is N stand for periods at the interest rate. So after we know the meanings of present value of annuity, the formula, and the meanings of terms in the formula, so let's look at the example. We need to how we want to find the present value of annuity. So the question is, find the present value of an annuity with periodic payments of 2,000 ringgit every 6 months for a period of 10 years at an interest rate of 6% compounded semi-annually. So from this question, we need to clarify and put out all the information given in this question and put there. So A, we do not know how much, and R is 2,000 ringgit, and I, these have a 2I, which is capital I stand for the interest rate per year, and little I stand for the number of compounded per year. So capital I is 6% and little I is 2, and then R, how we find the R is interest rate per year divided by number of compounded per year. We got 0.03, and then T, which is number of periods, is 10, and the last is N. We find the N is number of compounded per year multiply number of years. So we got N is 20. After we got the information given and we calculate all this, we put all this information in this formula, which is A, we do not know how much, and R is 2,000 ringgit multiply 1 minus 1 plus R. R is 0.03 negative N, which is N is 20 divided by R is 0.03, and we put there. And after we calculate all the
in the formula, we got the answer 29,754 ringgit 95 cents. So we got this answer for the present value of NET. So this formula how we find this present value of NET. So we move on to the next is future value of NET. The meaning of that is the total amount of money that will be accrued by making consistent investments over a set period. So in short, we don't know how much the payments in the end of the year. So they only have the series of payments. So from that, we use this formula, which is S equal R multiply 1 plus R and minus 1 divided by R. So from this formula, we can find the future value of NET. So what the meanings of terms in this formula? So before this, for present value of NET, we use present value of NET is A, but for future value of NET, we use as S. So S stands for the future value of NET ordinary, and R they have a 2R, which is capital R and little r. Capital R stands for the payment period or series of payments, and little r stands for the interest rate of periods, and the last is N stands for periods at the interest rate. So after we know the meanings of the formula for the future value of NET, so let's look at the example to find the future value of NET. So the question is, Aminah intends to invest 1,500 every month for 3 years at 12% compounded monthly. Find the future value at the end of the NET. So from the question, we need to find the future value of the NET. So we use the formula and we put all the information given to easily find by using the formula. So S, we do not know how much, and R is 1,500, and I, which is this have a 2I, which is capital I and little I. Capital I stands for the interest rate per year, which is 12%, and then little I stands for the number of compounded per year. The question mentions is compounded monthly, so the monthly means of we put compounded monthly is 12. So the R is we find is interest rate per year divided by number of compounded per year. We got 0.01, and then P is number of period, which is 3, and the last is M. We find is number of compounded per year multiply number of periods. So we got N is 36. So after that, we put all the information in the formula, which is S, we don't know how much, and R is 1,500 multiply 1 plus 0 plus R, which is R is 0.01, N, which is N is 36, and we put there minus 1 divided by R, which is R is 0.01. After we calculate all the information given in the formula, we got the answer 64,650 ringgit 32 cents. So this answer for future value of NET, and this formula to find the future value of NET.
Assalamualaikum. I will continue this presentation of amortization of loans. Amortization focus on spreading out loan payment over time. There will be 3 formula in this part. First, a periodic payment. Second is total interest paid, and the last one is principal outstanding at the beginning of the case period. Question: Lewis Hamilton wants to amortize a loan of 200,000 by obtaining a 10-year of mortgage at 3.5% compounded semi-annually. As Formula 1 fans, help Lewis find monthly payment, second, the total interest charge, and the last one, the principal remaining after 3 years. First of all, we need to highlight the important keyword. First, PVA will be 200,000, and for T will be 10, for capital I will be 3.5%, for small I will be semi-annually or 2, and to find R, we need to calculate 0.35 divided by 2, and we will get 0.0175, and to get N, 2 times 10 equals 20. For first question, the monthly payment, we will using a periodic payment formula. So the calculation will be 200,000 times 0.0175 divide 1 minus 1.0175 to the power of negative 20. So the answer will be 11,938.24. For second question, the total interest charge, we will using total interest paid formula. Calculation will be 220 times 11,938.24 minus 200,000. We will get 38,764.80 cents. For the last question, the principal remaining after 3 years. After 3 years equals 3 times I small I equals to 6, begin year 4 equals 7. So the calculation will be 11,938.24 times 1 minus 1.0175 to the power of negative 20 plus 7 minus 1 and divide by 0.0175. We will get 147,079.12. Thank you.